Let's apply our knowledge of some common quadrilaterals to compound figures. Let's look at rectangles first and review how we find the area of a rectangle. A rectangle is a parallelogram with four right angles, two pairs of congruent opposite sides. Opposite sides are congruent and parallel, so we're able to mark them like so. If I know one of these sides, I know its opposite's measure as well. All angles are going to be right regardless. Since we're finding the area, the angles aren't quite as important. However, all right angles help us identify that the shape is in fact a rectangle. Let's try to find the area of this rectangle. Since it's a parallelogram, we can use the parallelogram formula. Area is base times height, where the base is any given side and the height is a distance, a perpendicular distance between the base in question and the highest point on the shape. So base times height. So let's look at this example. We have a base of 6 and a height of 3. I always start with the general formula. Now I could have 6 as my base or 3 as my base, as long as I know that my height is the perpendicular distance. With a rectangle, the perpendicular distance is just the other side, which is why sometimes the area formula for a rectangle is simplified or changed to area equals length times height. So I'm going to use 6 as my base, 3 as my height, since the base in this case looks like the base of a shape, it's on the bottom. 6 times 3 equals 18 inches squared. The unit is always squared. Inches times inches, just like x times x, gives us inches squared. Squares are a more specific version of a rectangle. By definition, a square is a parallelogram with four right angles and four congruent sides. So all four sides have the same measure. If I know this side, I know its opposite. In fact, with a square, if I know one of the sides, I know all four. All angles are congruent, which means all four angles are right triangles. It's because of this relationship between rhombuses and rectangles. Rectangles have all four right angles. Rhombuses, or rhombi, have all four congruent sides. Squares have both of those properties. So based on that, we can use the same formula for parallelograms. Area equals base times height. The base can be any side. The height is a perpendicular measure, a measure that makes a 90-degree angle with my base, extending to the highest point of the shape. Whether it's given to me or not, I automatically know that the other sides of this square are 8 feet. This is because squares have four congruent sides. To find the area, I'm going to write out the general formula. A equals B times H, or base times height. In this case, my base and my height are going to be the same. The base is 8, and then the height is the perpendicular measure, in this case, both 8. 8 times 8 gives me 64 feet squared. I'm squaring the unit because I'm multiplying the unit. 8 times 8 gives me 64. Feet times feet gives me feet squared. With compound figures, I just need to apply what I already know about the area of squares, rectangles, and parallelograms to this new shape. The shape is made out of multiple shapes, so I need to find them. If I extend this line, I can see clearly that there are two rectangles. In this situation, we're assuming all angles are 90-degree angles. It'll either be represented visually or you'll be told that. Now that I know that there's two shapes, I need to find a base and a height for each one. That top rectangle, I know the height and the base. It's 2 feet tall and it's 7 feet wide, so there's our base. For everything else, I need to either infer the missing sides using the relationships I know about congruent sides in rectangles and squares, or I can rely on the additive postulate regarding line segments. So in this case, if I wanted to find this part of my compound shape, which is one of the sides of my bottom rectangle, I can notice a couple of things. 6 feet, which is the total length, that's the same 6 feet as we would see right where that x is. So we have x plus a bit above. If I look even further over, that bit above is 2 feet. So I know that x plus 2 feet equals our total of 6 feet. I can set that up as an equation. 2 plus x equals 6. I need to find two sides, two parallel sides that can be added up to equal a total length. 2 plus x equals 6. It's a one-step equation. I'm adding 2 to x, so I'm going to subtract 2 from both sides. 6 minus 2 gives me 4, so that means that this side is 4 feet. That means that either I can look at this shape as being 6 feet tall because of the measure 6 feet I was given on the far right side, or I know that it's 4 feet tall on the bottom rectangle and then 2 feet taller on the top rectangle. That's 6 feet total. Now I still only have one measurement for the bottom rectangle. I can't use the 6 feet, which is part of that bottom rectangle, but also part of the top rectangle. I might try to find this missing piece. You always need two known measurements. So I'm going to go through and look. I have 7 feet. The entire compound figure is 7 feet wide. I know that at the middle, it's 3 feet plus something. That something is my x value. 3 plus x equals 7. I can solve that by subtracting both sides, subtracting 3 from both sides, which gives me x equals 4. That's 4 feet. That means that bottom rectangle is 4 feet by 4 feet. I automatically know that that's a square. This knowledge of the individual shapes can help me infer the missing sides. Now in this case, I have enough sides, but if I wanted to fill everything else in, I could establish that that side, or that portion, between the purple line and the top of the shape is 2 feet, because that top shape is a rectangle. I could also infer that all of the sides around this square at the bottom are 4 feet, because all 4 sides are congruent on a square. I don't need that information, but sometimes if you get stuck, it helps to find all missing measurements. That way, something might click in. In this case, I need to find the area of each shape. My top rectangle is 2 feet tall by 7 feet wide. So I could say that my base is 7 and my height is 2. I'm going to start with my formula for area, base times height, which is 2 times 7. That gives me 14 feet squared. If I do the same thing for the bottom rectangle, which is actually a square, I'm going to take the formula for area, base times height, and I'm going to plug in 4 by 4. My 4 could be either side for my base, and my height could be either side because it's a square. 4 times 4 gives me 16 feet squared. And notice the unit is always squared. Last step is to add all of the areas together. One shape is 14 feet squared, one shape is 16 feet squared, so I add those together. 14 plus 16 gives me 30 square feet. On your own, break these compound shapes into 2 figures each. Use your knowledge of the properties of quadrilaterals and line segments to either calculate or infer missing measurements. Then find the area of each of the individual shapes you broke the compound shape into and add those areas together. That'll give you the total area of each of these compound shapes.